Hello. So I am Kevin. I am the CTO of Kurtosis Technologies, and here in our front row we have Galen, who is our CEO of Kurtosis. So we are going to do a little bit of an explanation of what is this Kurtosis thing, why is it relevant, what are the use cases for it, and we're going to cap this off with a demo. So at the very high level, Kurtosis is a dev platform for building distributed systems. So both Galen and I came from Palantir. And Palantir is a very big enterprise corporation. They have a bunch of Java microservices. They have the problem like pretty much all enterprise corporations do, which is how do you stitch all these microservices together? So you usually have a bunch of files that you need to initialize. You have a bunch of arguments that you need to call on all the different services. And they never really got a solution. So we saw imperfect solutions show up every now and again, but they never had anything amazing. So fast forward to the spring of 2020, and Avalanche had put out a grant for an end-to-end testing suite. So this end-to-end testing suite was prior to the ICO. How do we spin up the protocol? How do we perturb it in various different ways? And how do we test it to make sure that things are going to work as we expect? So we responded to the grant, ended up winning the grant, and we built the platform, the bones of what eventually became Kurtosis. So the problem that Avalanche faced, just like Palantir had faced, is you usually have a bunch of different components that all need to talk to each other. They all need to play well together. You need to create them at specific times and make sure that you're waiting for things to become available. So the idea behind Kurtosis is you take these various different components, make it very easy to instantiate each of these things, make it easy to stitch them all together, and provide an environment sort of as a commoditized product. So in the scope of Web3, what this usually looks like is maybe I am a dApp developer. I have the protocol that I want to deploy my dApp on, so that might be Ethereum or Avalanche or Solana or whatever. And I have a bunch of different auxiliary services on top of that protocol that I need to deploy into my environment. So I need to start the chain. I need to probably deploy a smart contract onto that. I need to spin up my indexer probably. I would like to probably have an explorer or a wallet, and we can see this representation right now on the screen if I'm not blocking it. And there's a bunch of all these different little components. Now, this process is or can be very painful to do. So you can do it once and that's fine, but then as your developers start developing upon your dApp, then it becomes more and more difficult to automate. So the solution that we have seen is we've got Docker as a containerization engine to make sure that all of your different applications can be shipped to users in a repeatable and portable fashion. And Kubernetes, of course, is building upon the work of Docker, mostly focused towards the production side. But that still doesn't answer the question of how do we stitch all these things together? How do we take all these different components, unify them together, and give you an environment so that my developer can say, hey, I want to test this particular part of my microservice architecture or my blockchain architecture, and I want to have just that and start spinning it up and iterating on just that. So Docker Compose tries to do that, but if anybody who's used Docker Compose is familiar with, you start to run into portability problems. So maybe somebody has created a volume on their local machine that contains a bunch of data, and when I give it to my friend, the dev next door, he doesn't necessarily have that exact same data. Or maybe you start getting port conflicts, and then there's no good way to share these Docker Compose files outside of a GitHub. Now, Helm tries to, which is Kubernetes' solution to the Docker Compose problem, tries to fix this. So Helm has templating built in. It has the ability to put Helm charts on various different artifact hubs and share them with your friends and back and forth. But again, as anybody who's used Kubernetes knows, this can often get quite complex. I had a friend who referred to Kubernetes as the black hole of developer time. And I think that this is probably an experience that those folks who have worked with Kubernetes in the past understand. So if we think about this at a conceptual level, Docker is great at prototyping. It's great at the just getting started workflow. And Kubernetes is great at the production workflow. But then you start to have this weird middle ground in between where Docker starts to phase out and Kubernetes starts to phase up in usefulness. And Kubernetes is, of course, very complex, that we conceptualize as this. This graph is, with the Docker and Kubernetes, basically the state of distributed system development today. And the aim of Kurtosis, the hypothesis upon which the company was founded, is that we can do something better. We can have a higher level API where Docker is, say, assembly and Kubernetes is assembly code of distributed systems. And then we can start building a Java, a C++, a higher level API on top of this. And this is accomplished through an architecture that is first and foremost focused around isolation. So this is the Kurtosis idea. The Kurtosis idea is every distributed system must run inside of an environment. And that environment is going to be composed of one or more different components. That would be your services, maybe your monitoring, ingestions, etc. Those all go inside of what we call an enclave. An enclave is like a walled garden. And everything you do inside of that enclave should be portable, it should be easy to work with, and it should be isolated from the other enclaves, so that you shouldn't have any weird interactions. You should be able to start as many enclaves full of maybe one enclave has Ethereum going on, and one enclave has Avalanche going on, and one enclave has Near going on. And none of that should be problematic. So the Kurtosis engine, the product, the technology that we've been building for the past year and a half, is focused around mediating interaction between these enclaves, these walled gardens, these little sandboxes in which you can create your services and manipulate your services. And then on top of that, we have built SDKs, we've built APIs for interacting with the Kurtosis engine. So on the far left, you can see that we have the Kurtosis SDK right here. And this is going to be the way that you can talk to the Kurtosis engine. And very concretely, that looks at things like, hey, how do I create this little sandbox? How do I create this, this walled garden that I have? How do I create services inside of it? How do I get rid of services? But also some more complex features that you're only able to do when you have this notion of an enclave, such as simulate network repartitioning between these services inside of an enclave, which we've seen in the Ethereum use case, where they wanted to be able to simulate a fork in the network when the Ethereum merge happens. So then we've built two interfaces on top of using the SDK. So we have the CLI, the Kurtosis CLI, and the Kurtosis GUI, which are the more user-friendly ways of using the SDK. So I'd love to jump over into a demo really quick just to show you guys the concrete meat and potatoes of what we're actually doing. But before I do, any quick questions? I know I just talked a lot really straight, so any points of clarification? Cool. So like I mentioned, Kurtosis is a CLI. Kurtosis is an engine that has a CLI for accessing it, more technically. And like I mentioned earlier, everything in Kurtosis has this idea of enclaves. Enclaves are walled gardens in which you can do your distributed system development. So the very first thing we must do in Kurtosis is create a new enclave. Can you build that up a little bit? Yeah. How's that? Cool. So the very first thing you must do in Kurtosis is create an enclave, create one of these walled gardens. So we have just created a demo enclave. And all of this is backed by Docker for local system development. So we can see that really what's happening under the covers is that a Docker network has been created, a Docker subnetwork has been created in order to house all the new stuff that we're going to do. So Kurtosis, like Docker, has the ability to go ahead and create new stuff. So if we wanted to create something inside of the demo enclave, and we wanted to create a service called web server, and then we wanted to use the HTTPD container image running on ports 80 here, then we could just go ahead and do this right now. So this is going to add a web server container, and already we can see that this is a little bit different from Docker. Because Docker, you must explicitly specify the port mappings that you're going to start interacting with. But in Kurtosis, again, we're first and foremost focused on development and testing. So if you want to iterate with the things that are inside the enclave, it doesn't make much sense if you have to start thinking about like, oh, which ports am I going to need in advance? Like basically you come afterwards and you're like, oh crap, I need to be able to get this port. But then what do I do? Do I shut down the container? So on. So, sorry, say again? I think. Yeah, so Kurtosis actually picks ephemeral ports. So you cannot have collisions. Port 80 locally is 5, whatever. So if I have a web server running locally, and then we do this? Yeah, so this will not actually be a collision. So this is port 80 listening on the web server container. So the web server container, which operates. Okay. And then if we, of course, go into our Chrome, we can see that, of course, we have access to this. So once you have something inside of Kurtosis, the idea Kurtosis is a platform. So we want to be able to do various platformy-like things. So as we have the Kurtosis enclaves, we can do an inspect here. And we can see that right now we have an enclave with a whole bunch of information coming out. And these user services right here, this is the web server. And it just prints the information that we have previously. But now we can start doing more interesting things. So for example, we have the logs, right? And if we want to print the logs of this thing, we could go ahead and tail the logs. Pretty much equivalence with Docker here. We can grab a shell to this thing as well. So if we wanted to start exploring the container, we can go ahead and investigate. We can start adding files and so on and so forth. And of course, the inverse of this, enclave inspect of this, again, to get our demo back, the equivalent to this is Kurtosis service rm demo web server. And then that's going to tear it out. And now we have a container which is actually stopped. So from Kurtosis's perspective, this has been unregistered from the enclave. But again, we are focused on dev and testing. So this has actually been left around in your Docker engine if you want to continue, if you want to go ahead and investigate the logs. And we can see right here that we have our web server container. Now, this is fine. Right? We're making requests to the Kurtosis engine, and there's many such requests that we can make. We have an SDK. That SDK has things like add service, remove service, get logs, etc. And I can even give you guys a little bit of a preview of what this looks like. So this is actually one of our unit tests, one of our internal unit tests that we use to test Kurtosis functionality. So we have a Go unit test that imports the Kurtosis SDK, and as we can see, the very first thing that this does is it creates an enclave. We have a defer function inside of it to stop it. Oh, yeah, sorry. Let's get this. Ooh, I'm actually not sure how to do this. Text size, maybe. I gotta apologize. I don't actually know how to build this up. Anybody know an IntelliJ? What's that? So, sorry, I don't understand. Oh, gotcha. Thanks. Perfect. So we have. So right here, we have the exact same steps that we took before in the CLI now happening inside of a Go unit test. So we have the SDK, and because again, remember the CLI is actually just a CLI wrapper around the SDK. There's nothing insanely magical about anything. Anything you can do in the CLI, you can do with the SDK. And then of course we add a data store service right here. And then the very last thing we do is just a couple checks to make sure that this works. This is all custom to the particular test. So our Kurtosis code is basically a two-liner with some error checking. Now, this is fine. Doing one-off commands is fine. But what's way better is if you can start to package those commands into a distributable form. Now, this is, I was mentioning Docker Compose earlier. I was mentioning Helm earlier. And Kurtosis has a built-in notion which we call modules. So if everything to Kurtosis is instructions to the Kurtosis engine, then we can package those instructions into a distributable form. And this is a Kurtosis module. So you can think of Kurtosis module alternately as a set of instructions to the engine. You can think of it as a Docker Compose on steroids, a Helm on steroids. So we have this enclave here. And we started a service. But what happens if we do a module inside of here? So we have currently we have two main modules that we provide. These are the Ethereum module and the Near module. We've had people request for an Avalanche module, so we're feeling out how interest for that. And this is going to pull down the module, which is again just a set of instructions to the Kurtosis engine, and execute that inside of our enclave. So we can see that the module is starting to print out bits of information about what it's actually doing. And here we're adding a bunch of services inside of the Kurtosis enclave that is going to represent a near network plus all of the auxiliaries on top of that near network. So once this comes back, which should finish in just a couple seconds, we can see that we get a bunch of URLs, which again, because Kurtosis is always binding all the ports to your local machine, you can now start investigating your local Explorer instance, your local wallet instance, and this is going to be fresh. So I could just utilize this and spin it up and tear it down. But of course, maybe I'm building a bridge. So if I'm building a bridge, it would be great to be able to have connections between two different blockchains. If we switch this to the Ethereum Kurtosis module, then we can go ahead and execute the same ideas of a bunch of packaged Kurtosis steps inside of the enclave to eventually yield both a Neo network and an Ethereum network. And then on top of that, I could use all the stuff that I've already done before, the service adding, to add any microservices that I might need, as well as deploying contracts to both of them for testing the bridge. But again, we mentioned that this enclave concept, this is something that is particular to Kurtosis. Whereas Docker gives you the low-level metaphors like the Docker network or the containers, Kurtosis is a layer above. So we have this enclave, and now we can start doing stuff with the enclave. Like I mentioned before, we have the ability actually to repartition networks here. Let's get this. You guys seen that? Maybe? Cool. So this is another unit test which tests network repartitioning. So being able to cut networks off from each other and create packet loss between them. So right down here, we actually see the call to the Kurtosis SDK, right here, the enclave context, which is how I could then simulate network repartitions between, say, the Neo network and the Ethereum network, or maybe between the various different nodes inside of the Ethereum network. So again, we have this enclave context where enclaves are isolated from each other. And as anybody who's done distributed system development knows, very commonly you'll hit an error, say something doesn't work, and then you want to show your friend across the way that that thing is broken, and you need to show the logs, and then you're asking the question, okay, how do I get that stuff out? So Kurtosis has the notion of a Kurtosis enclave dump, and we can output the contents of this entire enclave right here, and we can see that we get all of the logs as well as the spec.json. We've used this quite a bit when folks have troubles with Kurtosis. Is be like, cool, give me the enclave dump. And then we can get the actual, all the various different bits of information debugging about the enclave. And of course, the very last thing is being able to tear down an enclave. And Kurtosis will clean everything up afterwards. And when we end this destroy step, we will see that we have an empty Docker engine with no containers except the Kurtosis engine itself running. And all the networks have been cleaned up. So that's that's a really quick lightning speed run through of Kurtosis itself. Of where we are, that's Kurtosis right now. That's the tool right now. So what's next? Where are we going? As my little slideshow jumped ahead, right now we currently have Ethereum modules, we have Near modules, we have an ETH2 merge module, and we are contemplating building an Avalanche module. So being able to spin up an Avalanche network with a one-liner. And then you'd have the ability to create services on top of it, create services inside that enclave, and move back and forth. Now, why would that be useful? There's a bunch of solutions that once you have this, could potentially be opened up. And again, this is out for you guys. So if you guys are interested in this, please definitely tell us, because that's the driving factor behind creating one of these modules. And you can see we put a bunch of ideas on top here. We got bridges and we got custodial solutions. Maybe if you're doing white hat hacking, any sort of bug bounty, then having a local copy that you might not necessarily want to do on testnet or mainnet would be possible inside of Kurtosis. And the platform's only going to continue to build. So we want to add log grepping, so like basically indexing all of your logs inside of the enclave so you can search it, grabbing metrics, so CPU usage, memory usage, disk usage for everything that you would just get out of the box if you do this inside of an enclave. And then of course moving to the cloud. So being able to say with one web request, pressing one button on a website saying, give me an Avalanche network, and I'd also like to add in Ethereum as well, and I'd also like to plug them together. So that's what I got for today. Just again, we got Galen in the front row here who's being cameraman, and my name is Kevin. I'm the CTO and Galen is the CEO. We're currently in the process of building out the team and moving forward. So if this sounds of any interest to you, please reach out to us. We have a Discord. And all of our information is going to be on our website, which is kurtosistech.com. And that's our last stuff. Any questions? Anything?
What's your internal use case for security settings, sharing, and secret sharing, and things like that? Do you guys have any process for that? Mainly when you start doing larger investments, you have to worry about SOC 2 compliance and all that fun stuff. How are you guys handling that internally?
Yeah, so are you talking about like Kurtosis as the company with our web services that we expose externally, or are we talking about within an enclave?
What do you guys do internally? Because it's going to be different for every organization. But when you're talking about giving tools to developers to build things on, having an explanation to them on how you share secrets, say, to your AWS environments that you might have to pop up to. How are you guys doing that internally?
Yeah, so the real answer is right now, because we don't have anything running in the cloud right now, we don't have to deal with the secrets case. So the most that we have to do right now is how do you pass secrets into your CI builds? So everything that you've seen can run inside of CI and does run inside CI in every Kurtosis commit. But we're just leveraging Circle CI's secrets framework right now. One of the ideas among many that I've had in the shower has been like being able to provide a secret store built in with the enclave so that you could deal with secrets and perhaps potentially load secrets in a secure way that would then be available to your environments but would not be available to somebody using the exact same module, if that makes sense. So I know it's a little bit of a cop-out answer. I don't have that yet, but ask me again in a year and a half. Anybody else?
Do you see yourself as a replacement for truffles?
For truffle?
And maybe expansion to other networks.
Yeah, so we, I would say we're less specified. So we're not focusing on EVM specifically. So Kurtosis, the core Kurtosis code base is actually built to support distributed systems. So then on top of that, folks could build, EVM support. Like basically, probably the best way to put it is that you could build Truffle on top of Kurtosis. And then having that for all the various different chains that you want, like having that for Solana, having that for Near, that would be an ecosystem play on top of Kurtosis. So you could have your various different plugins for Kurtosis that would plug into all the different chains. And you could even imagine like a genericized truffle that is then pluggable to any different chain where the chain is started inside of Kurtosis, and then that becomes a Kurtosis module on top of it.
How would you go about like simulating various threat actors to like testing the security implications of a given consensus protocol?
Yeah.
You want to stress the boundaries of those. How would you go about setting up those perturbations and then extracting the information you'd want?
Yeah, so at the low level, we have seen use cases in the past where people basically simulate bad behavior, malicious behavior inside of Kurtosis. So if you ask me, I'm going to basically say that the tools are not nearly where I want it to be, where we have where you spin up the network, and then you can simulate those bad actors who are attacking the network. Maybe they're injecting bad data into the network, and then you can examine the state of the network afterwards and see if the network, for example, correctly rejected it as it ought to. Like in the case of Avalanche, for example, you'd want to make sure that people aren't like basically injecting bad data or like being able to lie in various ways and make sure that doesn't affect stuff. And in Kurtosis, that would basically look like maybe spin up a good node and then spin up a bad node and have the bad node start, sending bad data to the good node and then checking the state of that afterwards. Core Kurtosis does not have anything like for doing explicit bad behavior. What I would love in say 6 months' time is that we have a module that is explicitly designed to be able to do this. And I don't know if you guys have heard of Jepsen tests at all, in distributed systems, of course, right? This is it's a suite of tests in order to break distributed systems. We would love to have modules that would say encapsulate all the common Jepsen tests. And you can imagine the exact same thing for blockchain.
I think this is just maybe an expanded question as well. So, with Like, I think more and more we're talking about like network resilience, especially in the light of war and all that, especially eclipse attacks. Let's say if, internet is cut off for entire country, for especially you talk about all the distributed system tools coming over, right? But do you really see kurtosis, do you have tests for, let's say, if the network partitions and, comes back together, how we would recover from scenarios like this?
Yeah. You give me the easy questions. So yes, the answer is yes. It's actually what our internal unit test tests. We use like a notional API and data store that I built as a test. But we have a Go unit test that does exactly this. It tests what happens if you chop the network in half, verifies to make sure that there's no connectivity, which also tests the internal functionality of the repartition simulation inside a kurtosis, and then heal the network partition and make sure everything continues to work. And then there's, beyond actually just hard network partitions, there's the idea of soft network partitions. So what happens if I start messing with packets' contents, corrupting packets? What happens if I start delaying packets? What happens if I drop a percentage of packets? I can do do interesting Poisson distributions of like when packets are going to arrive. So yeah, that's all inside of kurtosis actually as a core feature. What else can I answer? Or what else is confusing? Because I know I talk fast.
What are the limitations for writing the actual tests themselves? If you wanted to make a corpus of tests that do a specific set of things for perturbations, what do I need to use to do that?
In terms of what are the actual technologies that you need to use?
Yeah, like can I do it in any language or?
Yeah, so right now we support Go and TypeScript. Writing future SDKs is a big goal of ours as soon as somebody asks for it. So our goal, and that's actually one thing I forgot to mention. So both with Helm and with Docker Compose, you have to learn a YAML syntax that, of course, is not compile time checked. You basically run it and then see what happens. And one of our fundamental design features is that we think it's important to be able to have SDKs in the language that you want. So if you want Python, then we would want to have a Python SDK. JavaScript and Golang are our two most requested ones, which is why we currently have those SDKs. But yeah, once you have the SDK, you can basically, anything you can do in the Kurtosis CLI and more is available via the Kurtosis SDK. Yeah, I think I'm really running out of time anyways. So